Welcome to the session on IoT analytics. Why I have this particular screen is because what you're seeing on the screen is actually the real temperature which is coming from a sensor. And what you're going to learn today in this session is how you can connect millions of these sensors to Azure, be able to get insights from them, move some of the insights to the edge, and get your end-to-end solutions working from your true IoT analytics solutions. So let me start with introducing Shweta. Shweta is a senior dev from the TED team, and she's going to be helping with certain parts of the session. I'm Santosh Balasubramanian. I'm the group product manager for Azure Stream Analytics and Time Series Insights. So let's start off with why we are here. We'll talk through a few customer scenarios to start with. The first scenario I want to talk about is one of the first customers that we had, and I really appreciate bringing this scenario because this is in the medical use case. So Aerocrine is a company out of Sweden. They sell asthma devices, and one of the scenarios that they came to us with is, I want to do some remote monitoring for patients. So this device is actually even there in the Microsoft Health room, which is there in our campus. So with this device, a patient can go blow in or suck air in, because actually I do have asthma, so I know this. It is not just about how much air you can get out, but also how much you can take in. It's all about lung capacity. So they actually have apps in which me as a patient can sit in front of the computer and test this device, but a remote doctor can actually see how is the usage for this particular asthma patient. Not only do they do this, not only do they sell devices, they also sell services. These devices are expensive. So how do I monitor the environment around this device? You will see how such scenarios can be met today. Honeywell. Honeywell has built building monitoring solutions. So imagine this conference room, conference center, multiple conference centers. If I want to be able to monitor the health of what is happening in this conference location, then I need to be able to aggregate data from all the sensors which are here. I need to be able to do analytics on top of it. They do things such as, if heating increases in a particular part, how do I go and correlate it with what has actually happened down below in the equipment, so I can go and fix it as soon as possible. These two, which I've talked about and many more, they're already case studies, so I'm not going to go into details. If you go to Microsoft customer case studies, you can read about this and many more IoT and IoT analytics use cases. The third one I wanted to talk about was ABB, and this is something that we did recently. So ABB produces a lot of different parts and sells it to their customers. So think for energy grid customers of theirs, they have transformers that they sell. So what they want to do is they want to be able to sell a service on how do I maintain how reliable my transformers are. These transformers are very, very, very expensive. Any damage can actually cost millions of dollars of loss. Not only millions of dollars of loss, but also for the energy grid companies, this actually impacts them quite a bit because their customers are impacted due to this. So what they ended up doing was they used Azure IoT and Cortana Intelligence Suite and some of the things that I'm going to talk about today in order to do predictive maintenance and build neural network models, be able to predict failures 8 hours in advance. And I'm just showing you a quick dashboard, which is the first prototype dashboard that we built together. And they're able to even not just get the data, analyze the data, build models on top of it, but also visualize it using things like Power BI. So given some of these user scenarios, you can learn a lot more, as I said, if you go to the Microsoft case studies and see if there are things in the domains that you care about. Let me get into this session. Today in the session, we are actually going to walk over a scenario. Think about the ABBs of the world or the Honeywells of the world or any other customers who are doing manufacturing IoT or energy grid management or any of the other scenarios, and see how we can walk through everything that needs to be done for them to do their analytics. First, we'll talk about connect and ingest the data. How can I connect these sensors? There's a real sensor, which is BLE sensor, and get a gateway running. From the gateway, I actually do some processing there, send the data to IoT Hub or any of the other services, and then do post-processing later in the cloud. Next, we'll talk about real-time monitoring. Why is this important? If I think about the Honeywell use case, I have people who are saying, what is the current health of my building? This is not only in dashboards, but these are also alerting that can be done in data in motion. Think millions of sensors which are actually coming from here. Edge analytics. So you have heard Satya talk yesterday about Azure IoT Edge. You have heard George probably talk about it as well. He must have said Stream Analytics is one of the first services that we are enabling on Azure IoT Edge, which we actually did a private preview at Hannover Messe last week. I'm going to actually talk about this and show some early demos of this, early being the very important keyword. Time series insights. We're talking about data which is coming from sensors. This is time series data. When you think about time series data, it is not only what I do immediately in the real-time world, but also how do I store and correlate and make sense over this time series data, which requires everything from ingest to storage to analysis on top of this. There's also a new service that we did for our IoT analytics suite of solutions, and this is called Time Series Insights, which we released a couple of weeks back at Hannover Messe as well. And then I'm going to walk through a real example, if time permits, of how we are doing demand forecasting over energy data, which is actually coming publicly available data sets from New York State. So a big session. The first thing I wanted to do, because I always like to kind of show what you're going to see. So the first part with connect and how do you actually send the data to the cloud. For that, I have the sensor. This sensor, which is the sensor tag, is connected to my laptop. And think of my laptop actually as the gateway. So you could have any of the other gateways which all the sensors connect to. And from this gateway, the data is being sent to Azure. And IoT Hub is the first thing in Azure where it's being sent. So what I'm going to request Shweta to do is walk through the connect and ingest from your sensor.
Thanks, Ashish. Hello, good morning. My name is Shweta, as he's introduced me. So before we get into what's analytics in the Internet of Things era, we wanted to spend some time to understand what it takes to collect that data and send it over to the cloud. Now, this is the ideal world, right? All our demos, even the dev work we do, we take a Raspberry Pi, we load some programs on it, the program which is reading some temperature or whatever, it's reading some data, ingesting it at regular intervals into a large-scale message ingester, in this case, IoT Hub, and then we process the data. Now, while we cover a lot of part of analytics on the cloud, and that's where we talk about processing data at large scale, in the real world, we don't just have one device, right? We have thousands, if not millions, of these devices. And to add to the complexity, these are actually different devices. You will have voltage sensors, you will have temperature sensors, and these devices are actually sending data in different formats. So that's real world, right? You've got millions of devices, hundreds of formats. Some would be sending a hexadecimal, some would be sending temperature data in JSON format. Now, so it's very clear that when you're actually building a real-world, large-scale production system, you need to do a lot of processing before you ingest into the cloud, right? Now, that processing could be where you have extremely low-power devices that only work on Bluetooth, or they don't have Wi-Fi capabilities, they only have TCP or Ethernet. Or you have legacy devices. You already have devices that have been manufactured and they send data in certain format which is not compatible with the new age protocols. Then you might need to do a lot of conversions to make sure the data is, be able to process it on the cloud. You might need to compress because you have a lot of data that's going in. And you might need to collate from low-powered sensors. and of course, take real-time actions. Because a lot of times, you do not want to wait for data to go into the cloud and then run through analytics and then come back with an action that's to be taken. You want the action right now. For example, if you detected an anomaly in one of the equipments, you want that action right now to switch it off. So you can't afford to, with the latency of it going to the cloud and processing. So we want to talk about Azure IoT Edge, which is a framework which you can easily use to build your processing on the edge. And if you take a look at the Edge modules, it starts with a broker, and this is a part of your framework. So the biggest benefit you have if you use Edge is that you get a decent framework which is scalable, and you can build on top of it. So you have a broker module where, let me take an example of what Santosh has been showing. So it's a Bluetooth device. So we've actually built a custom Bluetooth module that is sending data into the broker. And then we have a parser, which is another module that is a custom module that we've built, which is reading the data from the broker, converting it into a format, this is JSON format, and then sending it back to the broker. And then that data is being read by a stream analytics module, which Santosh will give or demo it in a detail after this. He does all the cool demos. I do the serious stuff.
But he does all the real development.
Thanks. So, and the data is going back into the broker. And then I'm using a built-in module. So now IoT Hub Client is a built-in module that comes along with the framework, which is taking that data and sending it out to IoT Hub. Now, before I show you the code, I wanted to, so when you're developing your modules, it's a very simple format that you follow. So you have a broker and a configuration. And when I say broker, it could be a message. You can give it whatever name you want. That's the framework that you get. So you have a gateway module that reads and instantiates all the brokers, and it sends the broker details and the configuration, which is the additional parameters. So let's say if my Bluetooth module has a parameter such as the IP or a MAC device, then that could be read from the configuration object. And then we have 4 sections. We have the create section, so you can add whatever code you need to when the device or the module is instantiating your connection strings and stuff. You have receive. Now the receive function is called or invoked by the broker. So whenever so it could be a continuous running function which is constantly receiving data, and you write your code on it. Start is when you want some code to be executed as a start. Now if you're generating data on your own, like if you're writing your own sensor simulator, that's where you would write a constant generator that is generating data. The destroy function is called when the gateway is destroying that module. So if you want to write some logs or you want to do something before that. And the next is the gateway. So the gateway.json, it's a JSON file. So that's what the gateway object reads to figure out what is my flow. So I'll have modules named with the exact path. Now that could be a JavaScript file, like a Node.js path. It could be a Java, or it could be a C. It could be so you support .NET, .NET Core, Java, and Node.js. And if you look at the source and the sink, that's where, so the source and sink are you can have multiple sources and multiple sinks. That's the flow, that defines the flow of the gateway. Now let me just show you the code that is running currently on this gateway device. So let me just zoom in a bit. We never learn, right? We zoom in at the last minute. So like I explained, so this is the message bus as a broker. It's an object which will receive. This create function is simply instantiating the objects. And if you look at the receive functions, so this is just printing, and it is instantiating. It's getting a message constantly. That's the Bluetooth module, which is sending a message, and it is receiving that message. And this is as simple as when you want to send it back to the broker, you just do call the publish method. And it automatically starts publishing data into the broker. Similarly, I just wanted to show you the the IoT Hub client, which is very similar. I'll just, like here, you're passing the parameters, like the connection string. It instantiates it. And when it's receiving, it's running some code. And it is going to send data out to the IoT Hub, right? So the message I'm saying is it's very simple for you to just download and build your custom code and have it running. And Edge provides all the peripheral around it for the messaging and for sending the data out into the cloud. Then you can also, the other thing is you can also filter. So if you want only some messages to be processed by the broker, you can just filter by properties. And this is the gateway which I was explaining. So these are various modules, and this is where it's defining that parse the method. The parser method is sending data to the Stream Analytics JS object, and the Stream Analytics is sending back to the IoT Hub client. So this is how you define the flow. And we can take some questions after the session, but over to you, Santosh.
Okay, thank you very much. Thanks, Shweta. And hope this makes sense, because this is the most integral part of, I can show everything else, but how do you actually connect and be able to stream data to the cloud and take actions? So I'm going to go back to the slides. Again, what we showed you is everything with the Azure IoT Edge, which we talked about yesterday. So now that we have the data which is streaming from here, what do we do next? I talked to you about the real-time dashboarding. I'm going to talk about how Azure Stream Analytics is one of the services that we are providing on Azure, which enables you to do this real-time analytics. One thing which I forgot to mention earlier is you will see this NRT PM team at Microsoft.com or at Azure Streaming for Twitter. If you want to ask questions, because we are taking questions only at some times between the slides, or if you have any doubt, please feel free to send email to either one of these. There are people from the team who are looking at it. On Twitter, they'll probably respond back as soon as possible as well. So let's talk about real-time analytics scenarios. I have a live dashboard. I have exactly what I saw before. How do I enable it? I want to be able to take alarms and actions. I want to drive a workflow, a human workflow, in case my vibration sensor has crossed a particular threshold. How do I actually kick off a process that sets a workflow for somebody to come and fix it? I want to take actions in which there are certain scenarios where I am getting data locally. I want to make a decision globally and then take an action back locally. These are things that you need: a complex event processing solution, a system that enables you to ingest this data, process this data in real time, and give results out of this. That is what Azure Stream Analytics is. It has very high programmer productivity. What I mean by this is, what we took the complexity of, think about temporal processing. Think about writing a logic, which is, in case my temperature or humidity in the last 5 minutes is 75% greater than what it was in the last hour, all of this temporal logic can be actually expressed in a very simple SQL-like language. There is also extensibility in JavaScript, and others will come soon. It is very easy to get started. I'm actually going to show that, and I hope you actually agree that any of you guys can start it by the time you leave from here. It's fully managed. What I mean by that is, all you need to do and all you need to think about is, once you have your data in your event broker, be it IoT Hub or Event Hub, in this case IoT Hub that we're talking about, you literally have to go to the Azure portal, click a button, and that is your whole provisioning step. The only thing you have to worry about is, how do I write my logic? And this is where, when we talk about TCO, right, it is not just about cost of equipment, it's also cost of getting started, developer productivity, which we have thought about a lot. There's Visual Studio integration and other things I'll talk about. And mission critical reliability. You have all the SLAs which is provided by Microsoft services, You have compliance, HIPAA, SOC, and all the other things that you need in order to make this an enterprise-ready application. Now, I've been talking about developer productivity. What do I mean by that? So anything that if you know SQL, like literally, if you want to say that from this particular millions of these temperature readings which are coming from this particular place, I just want an average reading, I can literally write that logic in 3 lines of code. Select average temperature from my IoT Hub input, group by tumbling window of 5 seconds. If I want every results 5 seconds. That's how easy we have made it. But there is not just these simple use cases. We have different windowing functions. Think about hopping windows, where you have windows, but you want intermediary results. Or I want a result whenever an event enters or leaves the system. There are things like sliding windows. We have temporal functions like lag, and a lot of other things, including mathematical functions. And I'll also talk about geospatial. I have a link to this advanced query patterns. You should look at this, because I've been talking about the easy things, and I'm going to show the easy things just to get started. But you can do things such as, when events are missing in the system, how do I know what was the last event which actually came in the system? How do I fill in a payload, because I'm only sending incremental events? So things like this, which are very essential for sensor data analytics, that is the thing that we have worked on in here. Very quickly, the way this works is we have, sorry, I'm trying to find my mouse. I'm just going to be interesting. So I'm just going to walk through this. So we have applications or devices which send data to event brokers like Event Hub or IoT hubs. And we also take inputs from blobs. Stream Analytics is where you're doing your real-time processing. And then you can easily write out to a variety of different stores for your own purpose. For example, if you want to do real-time dashboarding, we have a connector to Power BI. If you want to store data after cleansing the data in motion or enriching the data with additional information such as topology for each payload, you can do that by saving it into long-term storage solutions like Data Lake, DocumentDB, SQL, and other things. You can also kick off automated processes. So we also connect to Service Bus, Event Hub, and a bunch of other things. And all this connectivity is seamless, which I'm going to show you in the demo. So let's go to the demo. The example of the demo is exactly what I'm going to show. So what I'm going to actually show in this demo is, how did I get this live dashboard working? Okay, and I promise you it is 1 line of code to get this working. So the things which are happening here, and I apologize, now I'll have to switch between a few different windows, and you will see why. My BLE sensor is connected to Bluetooth to my laptop, and because I had to go to the advanced settings. So in here, it is connected to sensor tag. Then I have an application which, oh, I'm sorry. I'm doing the thing which, I'm looking at my screen, and I could just look over here. So again, this sensor is connected through Bluetooth. And then this is my gateway application. So think about my laptop could be just a big gateway server where everything connects to. And this is streaming data to IoT Hub. Now the question is, how did I go from this streaming data to my live dashboard? For this, I use Azure Stream Analytics. What I have done is, in Azure Stream Analytics, I can click this plus button in Ibiza portal. People who are familiar with Ibiza portal? Okay, few. Anybody heard of Azure Stream Analytics here? I'm actually curious. There are a few people. Thank you guys for that. So I can go look at start an Azure Stream Analytics job. And once I start an Azure Stream Analytics job, I can actually do all the other things that I was talking about. So imagine I've already clicked on this and I've started a new job. So now let me go back to the job. And my job is, all my jobs are here. A job is basically the container where I put all my logic for real-time processing. Think about that. And this is a very simple job. I basically have an input. My input is the IoT Hub. And you can see this is the IoT Hub. And if you saw the code that Shweta was saying, it had said there is an edge demo IoT Hub. This is exactly that hub. How I put it, I literally just enter configuration, and automatically Stream Analytics starts reading from it in real time. After that, how do I do an output? All I have to do is go to my output tab and say, add a plus button, and say Power BI is the output that I want. Once I do this, nothing else you'll have to do. We automatically write every event, all the computed events, down to Power BI. I can have multiple inputs and multiple outputs in the system. And then my query. And I'm going to show a very, very simple query logic here. All I'm doing in this query is I'm selecting all the data, select star, into Power BI output from edge input. And edge input is the alias of my IoT hub. That's all I needed to do, literally, for getting the code which is coming from my IoT hub to my Power BI. I'm showing you a very simple thing, but I purposefully actually had this page open. And you can actually see, you can do a lot more complex things here. You can do things such as detect duration between events. And the reason I want to show you is just to show you, like you have a link to the page, you can see it. Detect duration of conditions, fill in missing values. So even though I have shown you very simple things, you can actually do a lot of complex processing with a very simple SQL-like language. Hope this explains what Azure Stream Analytics is at a very high level, because I need to dive into a few other things. We have other tutorials in order to understand that better. So now let me go back to my demo. To my slides. I need to start this. Now that you know what we are doing here, let me tell you a few other things you can do with our real-time streaming solution. You can join multiple streams together. And this is an important thing. I can see cause and effect between two completely different streams which are happening in the system. And these are temporal joins. I can add static data to it. So I can augment my real-time data with static data that I call reference data. I can have custom code currently with JavaScript. I can call out to Azure machine learning models. There's built-in troubleshooting, debugging, Visual Studio plugins that I'll try to show. And I can also scale out. This is a true scale-out architecture. So I can actually partition my workload and do scale-out partitioning over gigabytes of data which is coming into the system. And then, of course, there are temporal semantics, where I can actually set policies for event ordering. I can manage latencies between gateways and different buildings and different locations, all of these through just configuration. This is the power of some of the things that we have done through Azure Stream Analytics. Another thing, because this is an IoT analytics session, I really wanted to pull out one of the capabilities from Azure Stream Analytics, which is geospatial functions. This is very important, because one of the main things I've heard in Industrial IoT 4.0 when I talk to customers is they want to go and they want to do things such as asset management. I want to do fleet management. So do things like this. You need capabilities of not just getting the GPS data, but being able to process that GPS data in real time. I want to be able to know when my car or my fleet actually enters a particular region. So for doing things like this, we have actually given you SQL-like functions which can act on real-time GPS data. So I can create points, I can find distance between two objects, I can find if an object is within another object, and a few other functions like this. And this can be used for a variety of different scenarios. Think of scenarios for phone tracking, connected cars, asset tracking, fleet management. A variety of different and new scenarios now can be done with a few lines of code. And I want to show you examples of these lines of code. If I have time later, I'll actually show you a real demo of fleet management and how we get it working. So generate an event when a car when gas is less than 50 kilometers from a car. So all I need to do is location, c.location, and s.location, which I'm basically getting, which is the GPS coordinates, when that is less than 50. Okay, so this is how simple you can actually think about. You can write your code and logic in. And you're going to get this slide, so you can see other examples of this as well. Any questions right now before I go to Edge Analytics? Okay, so I talked about Stream Analytics that we are doing in the cloud. But when we go and talk to more and more customers, one of the interesting things that they are saying, like Shweta actually had mentioned a little time back, I want to be able to do low latency processing, low latency command and control. If an action happens now, I need to be able to detect that action immediately. So think of that same logic which I said. If the humidity creates an anomaly, and the anomaly can be defined as if the humidity increases more than 50% in the last 5 minutes over what it was in the last hour, I want to be able to shut down a machine. So those kind of anomalies I want to be able to do. Sensor fusion at the edge is a very big example. One of the things we have heard is, I'm buying parts from a lot of different companies who are giving their own proprietary systems. But I can collect the sensor data from them. I want to be able to join the data between some of these different sensor and sensor types and be able to take an action on it. So I want to be able to join sensor data from multiple places. This is another scenario, so I can take an action. Compliance. I want to be able to remove PII data, like VIN numbers or other things, before I send the data to the cloud, right, in order to process in the cloud. Intermittent connectivity. Oil and gas comes up all the time. I'm working in oil and gas, and there are some customers in private preview with us. And I don't have connectivity all the time, but I cannot stop my processing just because I don't have connectivity. I need to do some real-time insights at that time. Interestingly, it also comes up in manufacturing a few times, which is surprising to me. And then another big scenario that we hear is, we have some customers in private preview who are producing from just one device 25,000 readings every 100 milliseconds. It doesn't make sense. I don't have the bandwidth to just send all of this data. I want to be able to reduce the data. I want to be able to take the most actionable data to send it to the cloud. Here is the POC with our private preview customer that we are doing. I do have devices which is producing 25,000 readings every 100 milliseconds. I want to be able to send the data every 5 seconds, an average, min, max, every 5 seconds. But if I hit a threshold, I want to send the last 5 minutes and the next 5 minutes raw data to the cloud, because then I can do learning in the cloud. That is actionable data. So how I can go between just aggregated and raw data, these are the scenarios that we hear. Actually, if you go down to the booths where we have the Microsoft booths, there's a big data booth, and we have actually one of the scenarios that we did with HP running there. You will see a big fan, which you see in the image right here, and this is connecting to the HP gateway. We are running edge analytics on it, and you'll be able to see how even our partners are working with us on this. So let me try to show a demo. Now this is, I'm going to be very realistic. These are very early bits. That's why we are in private preview. So pray for me. At the same time, let's see if this works, okay? So I'm going to go back. And you're seeing, actually, I'm going to do one thing, which is, I hope you like the picture of my kids here. I love this picture. Okay, so the one thing I'm going to do is, first of all, I'm just going to pull one thing from another desktop to make it easier. I apologize, that's taking a few seconds. And you can see, because there are so many demos, it is easier to actually have a few different desktops. So as I had said, my sensor tag is sending data in real time to the cloud. And what it is doing is sending all the raw data to the cloud. This is connecting to an IoT hub. And Shweta showed you what IoT hub it is sending the data to. People who have used IoT hub before, I'm actually curious, or heard about it. That's great. So you might have heard people who have used IoT hub. There is a Device Explorer client also you can actually get. So what I'm actually showing you is the Device Explorer client here, okay? And I'm just going to click on monitor. And this has the configuration of my IoT hub, and very soon it should be receiving the data. And you're seeing that it's actually sending all the raw data. So this temperature is 76. Here, temperature is showing as 76 in the BI dashboard because Stream Analytics is sending to it. At the same time, also here you can see all the 76 temperature because that's what it is here. Now, what I'm going to show you is I'm not going to make any change to the cloud. And I'm going to try to actually make a change on the device, which is on my gateway, okay? So let's go through a scenario. I am going to my internal environment, my dev environment. And here, now I can create a job. And when I go to a Stream Analytics job, I can create one of two kinds of job. It's a cloud job or an edge job. So imagine I've already clicked on the edge job and I've created an edge job. And I'm going to walk through what this edge job is doing. So I've got to go back to my Stream Analytics jobs, and I'm going to select that particular job. So all I've done is I've created on edge, and As you can see, this is my dev environment, so there's a bunch of different things. So here is the edge job. This has some inputs, but people who are familiar with stream analytics or what I've shown, these are different kinds of inputs. This is basically saying, what is it that I need to read from the broker, and what is the format of it? And this is the IoT Edge broker, Azure IoT Edge broker. So I just said that this is basically going to read JSON format from the IoT Edge broker. Output again to the IoT Edge broker, exactly what Shweta had shown you, right? Now, let's think of a query. I'm getting all the raw data. What I want to do is I only want to get data when the temperature is greater than 85. So I'm just expressing this query as it is. Select star from input when temperature is greater than 85. Now, I am going to, and the only other thing I have done is I have gone to this device and I have written what is the configuration. So if you have used IoT Hub, you have to actually register a device. I've said what is that device configuration. And that device configuration is the device which is actually for this particular gateway. So I'm going to click on Start. And now I'm seeing what is happening. So it is starting the job, and it says that the job is starting. As you saw, I haven't done anything else in the cloud, but suddenly you see that there is no data coming to my IoT Hub. Even though you're seeing that from the sensor, there is data coming. And a second before I started the job, there was data continuously coming to my IoT Hub, or there was data which was continuously coming to my BI dashboard, and my BI dashboard has also stopped. So let us see what happens here. So 85 degrees is what I said. Let me see if I can do that. So you see, when I did that, the temperature went over 85 degrees. And that is when data started coming to my IoT Hub and data started coming to my Power BI dashboard. Does that make sense what actually happened right now? What I did was I defined a query in the cloud. I said what device I want that query to run in. I clicked Start. The query went and changed the device configuration. This is the ASA module, which Shweta had mentioned. This ASA module is now running the logic, select star from input when temp is greater than 85. And to do all of this, all I had to do was click on a Start button. And hopefully this proves it. But I'm going to show you something else as well. I'm going to go back and let me just stop this job. And once I stop the job, you'll actually see that all the data is going to be coming through the system once the stop command goes through. So the stop command is still going through, and once it goes through, you will kind of see, OK, now all the raw data is coming. So now you're seeing data which is 78, 79. So what I did right there, I actually went and said, the query which is running, I want to stop that job from running on the device. But I can do more interesting things with this. And this is where, when I'm thinking of cloud connectivity, just don't think this is normal cloud connectivity. The importance of the cloud is I can go and I can test logic. I can actually try a bunch of different kinds of logic which I want to run. I can say, I don't want all the data. Remember I talked about the scenario of reducing the data? I can say, I only want data every 10 seconds to come from here. This is as simple of a logic. In SQL, I can write it. I'll copy this. I can test this in the cloud if I have a sample data set. I don't have time, else I would have actually shown you that. I can go back. I can go to the query and say, now I want to run a different kind of a query. So once I have done the investment of actually deploying the modules, all I need to do now is look how simple it is to click a button, and that's it. This query gets deployed on the edge, and now you will get an aggregated result of only every 10 seconds. So everything that I've shown you on Azure Stream Analytics, actually not everything, there is one caveat, geospatial functions, we still need to get it to the edge, but everything else, I have shown you how automated this is being deployed to the edge. By the way, you guys are the first audience in the world to see this working. This is a true hybrid solution, cloud managed, intelligence solution that we are moving the intelligence from the cloud directly to devices. So let me prove that that thing has actually happened. You will kind of see now that results will only come every 10 seconds. So actually, once I click on start, you'll see results will come every 10 seconds. Any questions on this? Do people understand what we really did here right now?
Is the sample code out everywhere?
So this is a great question, because the question is, how do I get access to it? I think I'll change your question a little bit. So what you can do is, I have to go back to the slides. And in the slides, as you saw here, I just moved Stream Analytics from the cloud down to the edge. And this is the broker. I want to show you the link where you can sign up for it. So what you need to do is you need to go to this particular link. I think it is, I'll open it so you can see the link by yourself. And you will have to sign up for this particular private preview. So this private preview, once you go to this Qualtrics link, which is there in the deck, you sign up for it, the team gets this request, and we are actually getting private preview customers into the system. But you're seeing that this is something that we are not just pitching. It is truly working in the cloud. And all of these complex examples can also work that I had actually talked about. All right, so just to summarize, it's a unique CP engine, everything that we talked about, even the JavaScript, user-defined functions, custom code that I talked about can be moved to the edge using this. It is the same language for development across cloud and edge. And cloud management, we're also going to allow you to do things such as, how do I look at troubleshooting and debugging and getting all the manageability of the edge devices in the cloud. All right, I hope you guys found this interesting. Sorry, question is here.
Show the link.
Oh, show the link again is the question. Oh. OK, so let me actually duplicate. I apologize. OK, so this is the link. It's hard from this. You'll get the slide deck, and you can basically see that in there. Or just ping me after this. You saw the NRT PM team alias. I do need to go ahead a little bit. I apologize. The next thing I want to talk about really fast is time series insights. And this is a very important thing. Oh, yes. So this is what happens sometimes when you have to go back and forth. So thank you for reminding me. So again, everything I've shown you is real-time data analytics. But if I find an issue, I want to be able to look at not just the current data, but also historic data. Again, the important part is this is all time series data. So what we have done, and I'm going to go through this very fast, is released a new service called Azure Time Series Insights, which enable you with scenarios such as, I have my time series data, I want to be able to index this data really fast. So it is querying, analytics, storage, and visualization service all in one. Think about it like that, where I can visualize all my IoT data. I can do my root cause analysis very easily, and you can see this through the demo that I walked through. I can actually have different plants and different factories which are geo-distributed, and I can get a single view of data from all of these different places. I can do things, and there are some of our preview customers who are now more in production. It is in public preview, though, but they're using this in production, where they are saying that when I add a new sensor to the system, how do I actually monitor that this sensor is calibrated correctly? Because what we guarantee is once the data is there in the IoT hub, within a minute, it will be available for you to be able to visualize it, and you will see what it is. And the last is, I talked about everything, and I'm going to show you this demo, which is there on our portal. But we provide you APIs, so you can take all the value of this time series insights and embed it in your own application as well. So that is another essential part of it. So for the demo, one of the things I'm going to do is I have some data which is from a manufacturing plant, and there are geo-distributed plants, which is all going to an IoT hub, and then time series insights service. The first thing I'm going to show you is how do I actually do that. So I again need to go to the Ibiza portal. I need to click on this plus button, and then I will search for a service called Azure Time Series Insights. Once I go there, just put your name, And, oops, you guys are going to be very familiar with my kids by the end of the day. Sorry, there is something which just happened on my screen, and I just lost my screen. I needed to go to duplicate. I did something wrong. OK, so very quickly, while this is loading, what you'll have to do is you'll have to go to the Ibiza portal. Here, I'll actually show it to you because this is important. Internet of Things, time series insights. And in the time series insights, all I need to do is say, what is my environment name? This is where I want to collect all my time series data. And what are the different SKUs? It is there currently in 4 locations in public preview. And of course, we are going to go to multiple locations, 2 in Europe and 2 in US currently. And that's it. I click on Create. After that, I go back, and I'll show you the configuration in the environment that I've already built. I say, what are my event sources? Again, just like Stream Analytics, all I do is I select, and I click on Add. I add whether it's my Event Hub or IoT Hub. In this case, we have IoT Hub. I can have multiple event sources which is coming into the system. I can add reference data, because in IoT, we have heard it's very important to add topology information. So we allow you to augment this data in motion, which we are storing, with data at rest that you are actually entering. I can give permissions. And once you do all this, what you get is all of your environments. So one of the important things about Azure Time Series Insights is this is zero coding. You're just putting your configurations, and automatically, in real time, we are reading the data which is coming from your IoT Hub. We index it within a second and make it available to you. In this particular demo, what I'm going to do is we have collected data from a bunch of factories, and we have collected it for a 1-month range. And there are millions of events. In Azure Time Series Insights, you can have from 1 million events a day to 100 million events a day, depending on the SKU that you want to ingest. That is the scale we can go up to. You can retain this data for 30 days. So this is one of the examples I want to show you. So imagine there are data coming from one of my factories. I want to see what is this data. And I'm just selecting some time range, right? So here, I'll just select like 5 days of time range. Right-click, click on Search. What you saw right now is nearly 5 million rows were searched in milliseconds. I'm going to actually show you that again because this is important. I'll actually go and select more data if you're interested. But the interactivity of the search, in this case, 11 million events. Interactivity of search is very essential and key to what we have done in Azure Time Series Insights. This is across historic data and real-time data that you can actually search. After that, I'm going to go back because the purpose of this demo, which will show, is more in this particular time range. You can do things such as, I want to be able to see what are all the things which are coming through my system. So one of the important value adds of Azure Time Series Insights, you don't have to go and do your data prep. You don't have to actually define your schemas. This learns the schema. This learns what are your measures and what are the different dimensions which are there that I want to do. So here is an example. I haven't done anything but just connected it. And already the system knows that there are a bunch of different types of data which is there in the system. I'm going to click on types. And I see there is data which is coming, pressure, temperature control rate, vibration, production line, and a bunch of different things. I can actually choose one of these measures and say, all right, I want to see what is happening across all my different geo-distributed factories. So you're seeing how I'm actually just navigating through this time series data, and I'm getting these insights. I'm looking at what is my production line load, and I see, wait a second, my factory 1 and factory 3 is OK, but factory 2 has suddenly dropped, right? So let me put my audience. I am the person who has got an alert because I'm having an issue in the system, or I'm the person who is doing some analysis into it, and how easily I'm actually going through this thing. OK, my factory 2 has dropped. Let me do some more research into it. I can now add additional terms. When I add a term, I can actually do correlation between searches. So here is a term I'm going to do. I want to see what are the alerts which are actually coming here. I'm sorry. I think it was just an alert. And what I see here is when my factory 2 load dropped, there were alert events which I had also pushed through the same IoT hub, which I had picked up at that time. Now, here's an important thing. I am going to show, I'm going to go back, and I'm going to basically show what are these alerts which are happening, so I can explore the events. And this is a very essential part of what you need to understand. I'm showing aggregates here, right? 2-hour aggregates. It's showing that there were 20 alerts in 2 hours. But there is all raw data. All these aggregates are computed on the fly as the actions that you take. This is a very important value add of what we are doing. You can go all the way down to the raw data to see that it's the high temperature alerts which is causing this particular issue. So now that I have done that, I can go and say, let me do some more analysis. I see there are temperature alerts which are causing this issue. I can go here. I can say, what is my temperature by different factories? So you certainly see that in some of the cases, my factory 3, the temperature has dropped a little bit. So I can also see not just the average, but show me the min-max of these temperatures. So see how visually I can look at all the different time series data which is indexed, and I can actually explore individually each of these sensors and sensor types. So I can just look at here, my factory 2, when the temperature increased, alerts started getting fired, and my production load fell down. And trust me, I haven't actually gone and simulated or done any of this data. Somebody from my team had done this, and I didn't actually ask him to do it this way. But at the same time, the important aspect is I can visually compare and contrast at the same time across all of these different things. Now I'm going to show you another example. Once I find this out, I want to do more research. And I can save this research and do additional research because we give you the ability to save your queries and share your queries and open queries with people that you have shared this to. So somebody from my team has gone and done more research to find out what exactly is happening at that time. So you can see here, when the alert is fired, the temperature got increased. The other variables, such as pressure and vibration, are normal. But the interesting thing is, this particular thing, which is the temperature control unit, actually started dipping before this alert got even fired. So what I did is, by just bringing up, and I can create this, I just opened a view, I can just bring up all the different sensor types and start comparing them and see, at this particular time, what is the cause and effect. So I can actually make an assumption that, let me go and do some research over what happened at a particular time when the temperature control unit actually fell down, right? And these are the kinds of things that people want to be able to do with time series data. It is not just about storage and being able to do queries. I can do a lot of different kinds of queries on this. For example, you saw these predicates that are being created. I can actually think SQL where clauses, and I can write a lot more information after the SQL where clauses to be able to get my data. I can filter the data as well. I can say all I want to look at is the temperature and nothing else. And I can use regular expressions to do this filtering of data. So hope this makes sense, because one of the other things that I want to show you in this particular thing is also, once I'm able to go and find all the information, be able to correct the information, if I want to go and validate, is my system working correctly, what can I do? So now that I've done this, I can actually go back, and you saw all that aggregation. It's taking me down to a 24-minute scale. But to validate if my 24-minute scale is OK over the rest of the month, I just need to click on this button, and you see 6 million events. I can see that when the temperature control unit was fixed, alerts stopped firing, and things got OK. There was another alert here which happened because my vibration sensors were bad. But think about how you can go and optimize your production lines and other things using time series insights. One last thing I want to show you is, this is basically showing all the temperatures by all the devices. And it's very hard to read. You can basically see the temperatures which are going positive. Some are going higher, some are going lower. So what we have done to ease the visualization is giving you heat maps as well. So a heat map actually shows you what is the anomaly which is being basically generated by the system. And I can interact with this heat map. I can say, why is it red here? I can basically go and zoom into this particular heat map and understand what is going on. I can look at individual results and say, I want to explore the events only when that is read. So hope you're able to understand the value proposition of what we are trying to provide here with Azure Time Series Insights. Easy to use, no code, schema agnostic, like it learns from the schema, and everything can be visualized and in your own APIs. One thing I did want to say, and as always, I'll have to do this whenever I'm sharing the screen. Customers like ThyssenKrupp used us even before we came out in public preview, and they are using this in order to be looking at the telemetry across all of their devices. There are other customers as well who are there in the blogs that you can see examples of. This is a public preview service launched last week. You're more than free to go to the Azure portal, and please do sign up. I'm very proud of what we have done here because I really feel we have understood the customer problem, and rather than just giving storage or some query language layer, thought about how we can go and help solve the customer through visualization and APIs as well. So to summarize, you can get started in seconds, global view of your IoT data, and leverage the power of time series in your applications. So if you want to learn more, one of the folks, OP Ravi, the PM on this particular product in my team, he's going to have another session at 12:30 in Tech Talk A. The last thing I want to show you, and I have a few minutes for this, is energy demand forecasting. Actually, I'll take one question if there are any questions. There is one question.
You mentioned 30 days.
Yeah.
You want to store for like a couple years.
OK, the question is, I mentioned 30-day retention if I want to store for a couple of years. Currently, Azure Time Series Insights gives 30 days of retention with the S1 SKU and 100 days with another SKU, which we call the S2 SKU. But of course, we have got that requirement. How do I archive the data, or how do I increase the storage? We're, of course, going to think about it and act on it. We're just in public preview, and we are getting all of these requirements. But on Azure, one of the things you can do is you can use something like Stream Analytics, and you can just write the data to any one of the storages as well if you want to do retention for a longer period of time, like Azure Data Lake or Blob or any of the other things. All right, I'll take a little more questions. I know I have a few more minutes left, so I'm going to go through energy demand forecasting really fast. So I have talked about, I do real-time analytics, I do time series analytics. Now I want to predict the future. So for this, what I'm going to show you is actually a demo. And I'm going to walk through the demo of this energy demand forecasting. If you click this link, you go to a site from which you can actually do a one-click deploy of this particular demo. So let me walk through the demo very fast. And this is in this desktop. So I need to duplicate my screen. So what you're seeing on the screen, come on, go away. Give me 1 second, guys. OK. So what you're seeing on the screen is, for this demo, we have gone and got data which New York State publishes for some of their substations. So they actually publish it on some internet site, and they allow people to actually take it for research purposes and learning about what is happening. So every 5 minutes, they actually publish data. So the data is coming from a variety of different places, from New York City to different places in New York as well. And what you see here is a real-time graph of every time a data point is actually published. We go and read it, and we are basically sending it to Stream Analytics and through the Power BI dashboard, so I can see what is happening now in my system. Then the insights. This is an important part. I have what is the demand in the last 24 hours, and this is being computed as well. And I had told you about the windowing functions, where I can have a tumbling window where every 24 hours I get a result. I can also have a hopping window where I can say, with a 5-minute hop, I want what is the results of every 24 hours. So every 5 minutes, I come to know what is happening every 24 hours. That's what we have actually done here. What is the average demand per substation? Some of these things are there. But the most interesting thing I feel in this, what we have done, is we have gone and forecasted what is going to be the demand for the next day. And how do we do this? This is the interesting part. We are talking about the same thing. I am getting data which is coming into my IoT hub. I'm being able to take the data, stream it to a real-time Power BI dashboard. But I can also use the same stream analytics and write it to a store from where I can run my machine learning models on top of it. So what you see here is the forecast. And I'm going to actually do Control 1 so you can see this a little better. Give me 1 second, guys. So here you see the forecast. So the black line, and you just saw that move, is what is the demand. What is the red line is the forecast. And you saw that the demand has been very close to the forecast. I want to be able to see the history, now, and predict the future. And what is the low 95 percentile and high 95 percentile of the forecast? This is basically saying what is the accuracy of my model. Why this is happening is because I'm training this model every hour, and I'm scoring on the data which is actually coming and showing that scoring. So you're getting as accurate results as possible. In order to enable all of this, and here I do have to jump my desktop, and this worked. This is really what has been done on Azure. We are reading the real-time data which is coming from the New York public site. We are sending it to an IoT hub. Then from Stream Analytics, we are showing it on the dashboard, which is the first data tab. We are writing it to a SQL server. And from this SQL server, we are using a service called Azure Data Factory, which I'm going to show you. And we have a Azure machine learning model that we are scoring against, putting the data back in SQL, and showing it in the same Power BI dashboard in the insights part. The red one is the hot path, and this blue one is more of the cold or the batch path. But in Power BI, I can show both of them to get my insights. So let me jump and very quickly show you what this is. I apologize for the windows, but you can see with so many demos, sometimes it's good to have it in separate windows. So what I have open is the Azure Machine Learning Studio. This is what my data scientist has done. So my data developer has gone and got the data and stored it. But my data scientist goes to Azure Machine Learning Studio. They can write their code in the language. So here they have written the code in R. So they've done all their feature extractions in R. Then they are using built-in models from Azure Machine Learning, such as boosted decision tree and things, which are world-class models which we provide as a part of the studio. Set up what is my training workflow, train the model, and then set up a web service. A click of a button, you can deploy a web service which gives you APIs that you can actually go and call it from your application. When I said Stream Analytics can call in real time a machine learning model, we basically go to this web service, send the data, get what is the scored data, and show it to the user. In this case, Azure Data Factory is going through this particular model and basically scoring what is the data which is there in the SQL server and bringing the data and showing it back to the user in the Power BI dashboard. So Azure Data Factory, I want to show you very fast. Again, this is something that you can create very easily. You basically say my SQL input. If you remember, it was the SQL Server service. There was Azure Data Factory and my machine learning model. It has activities. One of my activities is the AML batch scoring activity. So this says what is the API where I want my scoring to happen. Once my scoring happens, I put the results back in the SQL Server, which shows up in my Power BI dashboard. So if you see, every hour we run this. So every hour we actually train the model as well as we get the data so the model can be scored and we show the next day's result. So I hope you understand what I'm showing through here, how the services on Azure enables you to do everything from getting data with Azure IoT Edge. You're able to connect to your sensors. You're able to do the compression and other things which Shweta had talked about. Now we also allow you to run Stream Analytics on the edge. Once you get the data, you can actually get it to IoT Hub, which allows you to do your device management bi-directional. So not only can I get telemetry, but I can also send commands through the IoT Hub. Stream Analytics with all the values that we have talked about. Power BI for live dashboarding, as well as variety of different stores from SQL to Azure Data Lake to other stores where I can store my data and do post-analysis on top of it. Azure Machine Learning, where I can build my models. My data scientists can actually work with my data engineers, data developers. And I can build a model operationalize it, and we can use those same models in my pipeline in order to display it in a dashboard. So guys, this is what we had. Hope you found this interesting. I'm actually curious. The folks here who have used Azure Machine Learning, anybody? OK, there are a few folks. Great. Any questions? I think we are 5 minutes over time, so I should give at least a couple of questions. No? Oh, sorry, one question.
So for stream analytics,
yes.
I noticed that you're typing SQL code into a web dashboard.
Yeah.
Is there a mechanism for testing that and
yes.
locally? Or?
Yes, there is. The question is, in stream analytics, I ran something in a web dashboard. Can I test it and run it locally? I actually have Visual Studio editor or plugin for stream analytics. I can do this wherever in my house, and I can actually publish it to the web. I can actually even monitor. And once I show you my screen, you can see that. You can also test it in the portal, actually. But I thought it's to do offline development. You can do the whole thing in Visual Studio. Yes, another question.
For the time series insights, is there an API that you can access the data in it off a different, say, presentation layer?
Yes, the question is, for time series insights, is there an API that I can access the data in a different presentation layer? Yes, you can. We actually provide APIs, and actually the IoT SaaS solution also uses that. Any others? Yes, sir? The question is, can I parameterize this? What specifically? Oh, can I parameterize the values for the query from the APIs? Actually, one of the things that customers have done is, in order to run rules, they have said, what are the rules in my reference data set? And then I can write my query in a way where I join my incoming data with my reference data, and I can actually parameterize it that way. I can show you a little more later. Any others? All right, thank you, guys. I hope you found this useful.